Welcome back, students, year 9 boys and girls. We yet again meet in our series of chemistry lessons, and today our discussion is based on the preparation of salts by neutralization. The preparation of salts by neutralization. Now, in our previous lessons, we did look at the preparation of salts by reacting a metal oxide and an acid, which is also a process of neutralization. Then we also looked at the preparation of the salt by reacting a metal carbonate and an acid. Now, from the two, the metal oxide and acid gave us salt and water, and also the reaction between the carbonate and the acid gave us the salt, carbon 4 oxide, and water. Now, those are the two. Now, in our discussion today, we're going to be based on the preparation of the salts from the reaction between an acid and a base. An acid and a base, and in this case, we are looking at acid and alkali. Remember, in our definitions, alkalis are soluble bases. We gave examples of sodium oxide or sodium hydroxide, potassium oxide or potassium hydroxide. So the main objective for our discussion today is that at the end of our lesson, we should be in a position to explain how we can prepare soluble salts from the process of neutralization using an alkalis and an acid. Now, from what we've been discussing, we know that acids will react with the bases to form salt and water as the only products. When acids react with the bases, they form salt and water as the only products. Example, previously, from one of the lessons we discussed much earlier, when we react a metal oxide with an acid, it leads to formation of salt and water as the only products. For example, when you have zinc oxide added into dilute hydrochloric acid, then it will lead to formation of zinc chloride, which is the salt, and water. The resultant mixture will be a salt solution. But in our discussion today, we are going to be looking at the alkalis and the acids. For example, when you react sodium hydroxide with sulfuric 6 acid, there will be formation of sodium sulfate and water as the only substances. A reaction between sodium hydroxide and dilute sulfuric 6 acid will lead to the formation of sodium sulfate as the salt and water. That is exactly what we mean when we say a reaction between an acid and a base, and in this case, the alkaline solution of sodium hydroxide. Now, if you also look at that, then the sodium sulfate formed in this particular reaction is the one that we're calling the salt. That is the salt in this particular case. Similarly, we can also have sodium hydroxide reacting with what we call ethanoic acid. Remember that when we are doing some tests on the different solutions, and particularly the solutions that are either said to be acids or bases, we did use the litmus paper. And in that particular case, we were able to identify the different acids and the different bases. And one of the substances that we came up with as an acid was ethanoic acid. Why? Because it was in a position to turn the blue litmus paper to red, the same way hydrochloric acid and sulfuric acid can also do. So in this case, when you react sodium hydroxide with ethanoic acid, there will be formation of what you call sodium ethanoate. Sodium ethanoate, in this case, is the salt that is formed when the sodium hydroxide reacts with ethanoic acid. Now, the sodium hydroxide the ethanoate form is the salt that we're talking about. So it doesn't have to be hydrochloric acid or sulfuric acid. We can also have some organic acids coming in. For example, we can also have potassium hydroxide reacting with oxalic acid, which leads to formation of what we call sodium oxalate. Sodium oxalate is the salt that comes from that particular reaction. Now, in the reactions involving the alkanoic acids, normally the oic part of the acid, for example, we have what we call ethanoic. So that last portion of oic changes to oate in the salt. It becomes oate in the salt. That's why we have sodium ethanoate. From ethanoic acid, it forms ethanoate, sodium ethanoate. That is the salt that is formed from that particular section. Now, reactions in which an acid reacts with a base, leading to the formation of a salt and water as the only substances, is known as a neutralization reaction. A reaction in which an acid reacts with a base, leading to the formation of a salt and water as the only substances, is the one we're referring to as a neutralization reaction. So when you talk about the reactions between sodium hydroxide and the ethanoic acid, sodium hydroxide and the sulfuric acid, then those are the samples that we're talking about in terms of the neutralization reactions. Now, acids generally turn blue when litmus paper is dipped inside those particular solutions. The blue litmus paper turns red in acids. Blue litmus paper turns red in the acids, while in bases, the red litmus paper is able to turn blue. We did that experiment here, and we discovered that the blue litmus paper, when dipped inside the acids, they turn red, while the red litmus paper dipped inside the bases turns blue. That was a very easy identification of the substance or chemical substance as either acids or bases. However, this may not be the case, especially with the salt. When an acid, for example, reacts completely with a base, the salt solution formed has no effect on both the red and the blue litmus papers. When we have a neutralization reaction taking place, when an acid and an alkaline solution react, then the resultant salt that is formed at the end of it all in solution form, because we are talking of a salt and water, so it means the salt being formed is soluble and therefore it dissolves inside the water. So the resultant solution, salt solution formed, has no effect on both the red and the blue litmus papers. The salts which are formed in these particular reactions are therefore known as neutral salts. Such salts which are formed from these particular reactions are known as neutral salts. Why? It is because they don't contain hydrogen ions or hydroxide ions. Maybe we simply go backwards a bit. In the definition of an acid, we say this is a substance that dissolves in water, releasing hydrogen ions as the only positively charged ions. While in the definition of the base, we said that a base is a substance that in solution leads to the formation of hydroxide ions as the only negatively charged ions. So that being the case then, it means that when we have a reaction between an acid and a base in the neutralization reaction, then it means the hydrogen ions from the acid are combining with the hydroxide ions from the base, leading to the formation of the water. So such a resultant solution has no effect on the mass paper, and therefore that's why the salt formed is actually neutral in nature. Let's look at how this particular salt can be done step by step in our second segment. See you that particular time.